See, after physics class at 5:55, you take break. 12th NEET students take break, and your zoology class will start. Okay, you can go to that class. Okay.
Only physics class will be combined.
Yeah, only teaching. They have actually physics 2 classes. IIT students. One is numerical discussion. One is conceptual discussion.
Oh, I should have brought
Huh? Yeah, it will get. Once I received, I will forward to you. Okay, students. So once again, very good evening, everyone. So today we are entering into your 12th standard topic as per the schedule. Okay. Tell me, what is the first chapter in physics?
Electrostatics.
Very good, electrostatics.
Electrostatics is the unit.
Charge is static only, no? That's what it is called, electrostatics. Here in this chapter, we will discuss only charges are in the state of rest. Someone tell me, turn on rear light. Turn on only rear light. 2. Okay. Okay, so here electrostatic means, before that some questions I will ask. Already Parvez raised his doubt why charge is static. I think you might have seen in your day-to-day life, when if you see these edges at the tips of the collars, dust will be accumulated. Here only at the edges of this clothes only dust will be accumulated. Have you noticed? Can you explain that? Can you justify why the dust will be accumulated at that collars only? Huh? It is
Sliding. So,
yeah, very good sliding on. Why are you laughing, right? You told correct one. Because
it is attracting, that's why.
only one question. After that one question, gap should be maintained. Understood? Okay. After one question, you have to give me some space. Understood? So when we are moving frequently, there is a continuous friction between your collar and your skin. Understood? You know, every atom is made of 2 kinds of charges, positive charge and negative charge. Because of the friction, what will happen? This cloth is getting lost electrons. Yes or no? And those negative charges are accumulated on the skin, and the positive charges are accumulated on the surface. In the meantime, the air molecules with the dust specks also will be ionized because of the friction. Correct or not? That a negative charge with the dust speck will be accumulated and attracted by the positive charge. So that's what there will be more dust near the collar only. Say yes or no? Now you tell these charges are in the state of rest or in motion. When something getting ionized, those charges are considered in the state of rest only. The discussion is called electrostatics. So formally I will define one statement. This is a subject which deals with the study of the static charges or rest charges is called what here? Electrostatics. 12th need here only, madam. Yeah. Okay, so here in this chapter, we are going to discuss about only charges that are in the state of rest. Tell me how many types of charges are there? There are majorly 3 types of charges are there. See, Vishal, can you keep that aside? Zero charge, that's what. Okay. There are majorly how many types of charges are there? Positive charge. That is also called as proton. And another kind of charge is what? Negative charge. It is also called as, who is this? Yeah.
Sir, are you sharing screen?
Okay. Sorry, yaar. I did not share. So what is the second kind of charge is negative charge. It is also called as electron also. And third category is neutral charge, or it is also called as neutron. If you see the characteristics of the positive charge, could you please tell me what is the mass of the charge? Positive charge? Very good. 1.6 into 10 power minus 27 kilogram. Compulsory you have to remember on your tips. Star mark means compulsory at any cost you have to remember. And what is the charge of this proton? Plus 1.6 into 10 power minus 19 coulombs. Understood? 1 coulomb is a name of scientist, and he gave lot many contributions in the electrostatics. So in the honor of that scientist, charge is measured. MKS unit system is what? Coulombs. And if you look into this electron is having almost all negligible mass. What is the mass of the electron? Someone please tell me. Very good. 9.1 into 10 raised to very good minus 31 kilogram. Here mass of the proton and mass of the neutron almost all they are equal, and they are heaviest mass contributors in the atom. Electron mass is almost all negligible. So mass of the proton, mass of the neutron, it is almost all how many times? 1837 times to the mass of the electron. I mean almost all negligible. Say yes or no? Okay, so the mass of the electron, what is the charge of the electron? To balance the atom neutral, compulsory how many electrons are there, that many protons are there. In your chemistry you might be learned. Based on that concept, compulsory charge of the electron must and should be same as charge of the proton. What is charge of the electron? Minus 1.6 into 10 raised to minus 19 coulomb. Now if you take into neutron, what is the charge of this neutron? There is no charge, but only mass is there. So what is that mass? Same 1.6 into 10 power minus 27 kilogram. These are the basic characteristics of the electrostatic charges. Static charges, we never use current charges. How many types of charges are there, students, here? There are majorly three types of charges are there. One is static charge and other one is conduction charges. Let me introduce one very important principle that is called quantization of the charge. Quantization of the charge. What is this? Quantization means in the universe, for every object, for any charged body or uncharged body, the charge will be available as an integral multiple only. Integral multiple means if you take any system in the sense, if you take any charged body, for suppose here positive charged body is there. What is the meaning of the positive charged body? You know, every atom containing how many types of charges? At the center, nucleus will be positively charged, and surrounded by the nucleus, electrons are revolving in the which orbit? Circular orbit, elliptical. No elliptical, only circular orbits will be there. Correct or not? Because of some frictional force or some other forces, the atom may loses the electrons. If the atom losing one electron, so it will acquire one positive charge. Now, if it loses 3 electron means if it is acquired 3 positive charge. Then how do you define the positive charged body? Any body or any system which is lost or which is deficient of negative charges are called what here? Positive charges. Is my point clear? Understood. So here this will be completely, students, please you can discuss, but please with a low noise. Understood? So how can you define this total charge on the system? Respond. Let's say n number of positive charges are there. How can you write the total charge on this body? Q is equal to how much here? Plus n into charge of the proton. These 4 electrons, where they have jumped? Definitely they will not jump into the space. Definitely they are jump into the nearby system only. So if the electrons are jumped near the another system, you people respond what a total charge on the system? Minus 4 into E. Like that, charge will be available only like this. 1E, 1000 into E, or 2000 into E. Can you tell this kind of charge is available? E by 2, 3/4 of electron, or 5/7 of the proton. Like this kind of charges, can you see? That means there is no fraction of the electron charge. I mean, in the universe, the charge smaller than the electron is not available. What is the concept of quantization of the charge? In the universe, the charge smaller than electron not avail. Always total charge equal to integral multiple. How many multiple? Integral multiple of the charge of the electron. So what is the statement of this quantization of the charge? Q is equal to plus or minus n into E. This is the expression for what here? Quantization of the charge. One small practice problem based on the quantization of the charge. To gain positive 1 coulomb charge, what is that? To gain plus 1 coulomb charge, the body should lose how many number of electron? The body should lose how many number of electrons? Think and tell, right? Please don't give answers without thinking. Take your own time. Very good. 10 power minus 19, I think. 10 power 19 by Okay, let me check. 1 coulomb charge. For any system to acquire 1 coulomb charge, I mean positive charge, compulsory it should lose electrons, na? It should lose the negative charges. I am questioning you how many negative charges should be lost. So tell me, 1 charge of the electron equal to how many coulombs? Respond. Ma, Hari, 12th current batch. Please, you can use this room. This room is empty only. For half an hour, use this room. Okay. Quickly. So 1 electron containing how many coulombs of charge? Respond. 1.6 into 10 power minus 19 coulombs. Then 1 coulomb charge containing X number of electrons only, na? Yes or no? If you divide them each other, what do you get? 1 by X equal to how much? 1.6 into 10 raised to minus 19. So X value how much here? 1 by 1.6 into 10 power minus 19. Understood?
0.06.
Very good. So 10 power 19 divided by 1.6. What is 1 divided by 1.6 into 10 power 19 is called? Please respond. 1 divided by 1.6 means 0.625 into 10 raised to 19 something is there. So what I can get X equal to 6.25 into 10 power 18. Good evening, ma. Sit. So how many electrons or how many negative charges has to lose? Please respond. To acquire 1 coulomb charge, so that system has to lose how many number of negative charges or how many number of electrons? Exactly 6.25 into 10 raised to 18 negative charges it has to lose. Understood? Now, one small question I will ask you people have to answer. To acquire minus 10 power 2 coulombs, to acquire minus 10 power 2 coulombs, how many number of electrons? How many number of electrons should be added? Everyone have to answer this. How many number of electrons should be added? Everyone have to answer this. What, ma? Your first period will be physics. Second period you can shift to your room. Today, this week alone, IIT students, NEET students, physics, chemistry common. Max sir is on leave. That's what. Okay, ma. Today, 12th standard started. First chapter is electrostatics. Yeah. Okay. 6.25 into 10 power 20. Yeah? How many you are supporting? Very good. So it is very simple logic. 1 electron containing how many coulombs of charge? 1.6 into 10 power minus 19 coulombs of charge. But how many coulombs are there? 10 power minus 2 coulombs should contain.
Minus 10 power 2, sir.
Sorry, sir. 10 power 2 coulombs. I mean minus. So electrons, let's say n number of electrons should be added. How many electrons should be added to that system? I will assume n number of electrons should be added. So if you divide, what you can write? N equal to 10 raised to 2 whole divided by how much? 1.6 into 10 power minus 19. 10 power minus 19, if you take that side, 10 power 21 by 1.6 and 10 by 1.6 I can write, and into 10 power 20 I can write. So how many number of electrons should be added? 10 by 1.6 means 6.25 into 10 power 20 electrons must be added to that surface of that body to acquire what kind of charge?
10 power minus.
Negative charge. Means you have to spray the electrons. Understood? You cannot spray positive charges.
Inside.
Why? Because positive charge is nucleus. Nucleus you cannot take out of the atom. But electrons you can take inside the atom, you can take outside the atom, you can play with the electrons, but the positive charge you cannot spray. Now very immediately, let us go one very, very important concept, that is a charging process. What is the name of the process? Charging process. There are many methods are there to charge a neutral body. For example, I will take one neutral metal plate. Shall I call with your permission metal plate as a conductor plate? Conductor plate shall I call? If you take any neutral metal plate, just for sample, I will take one atom. According to Bohr's atomic model, at the center of the atom, what will be there? Positive charge,
Proton.
and electrons are revolving around the nucleus. Electrically speaking, how many number of protons are there? Same number of electrons are there. What is the total positive charge inside the atom? Respond.
Any.
Plus n into E. Say yes or no? N equal to number of positive charges and into charge of a proton. What is the total charge of electron?
Minus.
Minus n into E. So what is net charge equal to?
0.
Compulsory 0. Now I have taken one metal sheet. What I have taken? One thin metal sheet I have taken. Now I want to charge on it. The first process is charging due to friction, as I already explained. If you rub these surfaces with some other substances, I told you many times, what is the consequence of the friction? When there is a friction there between the two substances, definitely there is a loss of kinetic energy in the form of heat. Who will absorb that energy? It is very crystal clear that if you rub the two substances, lots of heat will be generated. My question is, who is taking that heat energy? Again, that electrons only will take. Not air, little is correct. Little air also will take, but we are neglecting the air. Dharani, understood. You are correct only, but we are completely not concentrating on the air. Only we are concentrating on the charges on the system only. So what will happen? Who will absorb that heat energy? Only the free electrons. There are majorly two categories of electrons. What are those? Tell me. In your chemistry, there are majorly two categories of electrons. What are they? Valency electrons and bounded electron. Bonded electron or bounded electron. Can you do anything bounded electron? Can you take them outside? No, you cannot take them outside. So you cannot do anything for the bounded electron. You cannot take out of the atom. But what you can do? Valence electron. Valence electron is very, very far away from the nuclear attraction. So very easily, by giving very less amount of energy, you can take it outside. Say yes or no? That's what, by this energy lost, if you rub the two surfaces, what will happen? The heat energy absorbed by those electrons only. Then what will happen? Those electrons will jump onto the another substance. So for example, this substance I am rubbing, what will happen? These electrons will jump from this material to this material. Like that, millions and trillions of electrons with the thermal energy. What is the name of that electrons are called? Thermal electrons. Why I am calling thermal electrons? Response, friends. They are easily affected by the thermal energy or heat energy. Yes or no? Those electrons easily will be jumped to that substance. As a result, this substance fully, what will happen? Positive charge, and these will be negatively charged. What the type of this process is called? This is the charging process by rubbing, or the charging process by friction. I hope everyone understood very well. Let me introduce the, I think in your childhood, simple experiment, your science instructor might be performed to you. If you comb, of course I don't have lot of hair, just you take a plastic comb and comb for several times, and take some small pieces of paper. If you keep that comb in that small pieces of paper, what will happen? The papers will be jumped onto the comb. What is the reason? Experiment. Scale, you can do it. No. You very good. Have you noticed it? Correct or not? Actually, in the process, what will happen, I will explain. What Srinidhi has done, he has taken one scale. What he did, you observed, he rubbed this scale with his hair. Between scale and hair, what happens? Tell me. Friction happen. So that scale lost electrons to hair. Now the scale is getting which charge? Only positive charge. Definitely, who are some enthusiastic, they will question me. No, that is not question. I will tell you.
What happened to the negative charge?
I will tell you. This glass is made of silica. Silica is a metal.
Yes.
Correct or not? Just now I explained. Here is a non-metallic substance. Correct or not? So if you rub for several times, the free electrons, I mean the thermal electrons, easily they will acquire kinetic energy and they will jump to his hair or surrounding air. So the scale will be which charged? Positively charged. Now immediately what he did, straightly he brought to one piece of paper. See, here the thing is, he did not touch the paper. He did not kept in contact. Are you understanding? Just he brought the positively charged body near the sample of paper. So what happened here? When you brought some charged body near the uncharged body, what will happen? Induction taking place. Induction means the nearest surface will acquire opposite charge but unequal. The reason is very simple. Like charges repel each other. Na? As you brought the positive charged scale, this paper is also containing, for example, one atom, for your understanding. It is containing one positive charge and one negative charge. So between positive charge and positive charge, what will happen? Repulsion taking place. Between this negative charge and positive charge, attraction taking place. Why? Because unlike charges attract each other. Understood? Even you are a student who are studying equal to you, definitely between you and him, definitely some not attraction. Equal, both are having equal IQ, equal marks means definitely some ego will come. Surfacially, you will tell you are my best friend, but internally you have lot of jealous and ego. Truth or not? Tell me. Correct or not? Openly, it is truth only. Understood? So here also like charges repel each other and unlike charges attract each other. So that's what it drag the electron, all the electrons very near to the positive surface, and all the positive charges will be repelled away from that surface. Here also this paper is charging. Knowingly, unknowingly, the
It is a neutral charging. There is no loss of electron.
Total charge is 0, Parvis. But earlier, what is the charge of the left side?
Negative.
Negative, na? Now it is charged only, na? You biased the charges or not? You polarized or not?
Polarized.
Yeah, polarized means negative charges you separated and positive charges also separated. Correct or not? Yes or no? So the negative charges are attracted towards the positive charge. Here the charging process is completed without any contact. Na? That's what this process is called induction, sorry. Electrostatic induction. It is called what here? Electrostatic induction. Electrostatic induction. How can you define the induction here? The process of charging of any system or the process of charging of any body without any contact is called what here? Electrostatic induction. Now there are many sub cases are there. For example, this is one conducting sheet. Conducting sheet means what? One copper sheet. This side positive charge and this side also positive charge. For your understanding, for suppose here this side plus 10 microcoulomb charge is there. Here also how many microcoulomb? Plus 10 microcoulombs of charge is there. Now if I brought identical copper sheet very close to it, now you people respond, what will happen?
Same thing.
Equal and opposite charge will be developed near the surfaces. As this is metal, I mean this is conductor and this is also conductor. What will happen? 100% of free electrons are there. All electrons will be attracted. Left side 100 positive charges are there means right side also 100 electrons will be attracted. So what is the charge will be? Minus 10 microcoulomb. What is the total charge on this side? You people respond. Very good. Plus. This is plus 10 microcoulomb. This is a electrostatic induction which is occurring in between the two metals. That two identical metal sheets. Same thing is applicable for different shapes also. Here I have taken one spherical charged one. For suppose here this is the already rubbed with some cloth or something. So it will lose electrons, na? Yes or no? It will lose some electron and it is completely positively charged, and those positive charges are accumulated only on the surfaces. Now if you brought one identical sphere, metal sphere, both are metals only. Now you people respond, what will happen? Negative charge will be developed on the left half. Correct or not? And positive charge will be induced. You have to call induced on the right half. If total charge is plus 10 microcoulomb means, tell me what is the charge on this? Very good. Minus 10 microcoulomb. And what is charge on this? Plus 10 microcoulomb. But as you counted what a total charge on this sphere?
0.
Very good. 0. But how do you say you charged it? Net charge is 0. To charging, what I will do? I will take one metal wire and I will connect on the right sphere and I will bury in the ground. That process is called what here? Earthing or grounding. Earthing or grounding. As you connected that metal wire or conducting wire only righter part. So what will happen? Only this positive charged sphere will not go to the ground. Can positive charge move?
No, sir.
Please respond.
No, sir.
Can positive charge move? Why? You only told it is heavier. 1837 times heavier and it is confined to Nucleus only. How nucleus will travel? Tell me.
So then how can I align like this?
I'll tell. I'm coming to that point only. That's what will happen. You know, the earth is nothing but it is a barrier of, it is a ocean of metals and minerals. Na?
Yes, sir.
At the interior part of the earth, like crust, core, mantle, many metals and minerals available in the form of the molten condition. Shall I call earth as a ocean of free electrons with your permission? Say sir, no. Why I am calling ocean? From ocean, if you take out 2 buckets of water, will it go down?
No,
If you add 10 buckets of water, tsunami will come.
sir.
Nothing will happen. Huh? So that's what in the earth planet also, if you add how many electrons, its charge will not increase. Total charge is always 0. Are you understanding? If you take out how many electrons from the ground also, the total charge never become positive. If you remove the electron from the earth, do you feel it is positive? No, still it is 0 charge only. Are you understanding? The total potential of the charge is always 0. Are you understanding? So that's what will happen. Few electrons are coming out of the ground and they are neutralizing all the charges. Say yes or no? Correct or not? Like that, after some time, what do you notice? After some time, you will notice only this will be as usually positive charge, but this will be only negative charge. Only this side will be negative charges will be there. Understood? And still it is grounded. And as there is a lot of space, now what will happen? So some uniformly distributed, but still it is confined to some, mostly confined to half of the sphere. That's all. Are you understanding? Now, definitely you people will ask me, sir, instead of metal, if you take some other material, metal means what? Conductor. What the conductor means? Which containing many free electrons. But like substances like plastic, rubber, mica, wood, do you say they do not have any electrons? Yes, they have electrons, but they are bounded electrons. You can't do anything. Plastic only.
Sir, then if we rub this, everything will happen, right?
They,
Then this is attracting paper.
Yes, sir. If we rub this also, then everything will happen.
see, nothing is pure plastic, Arvind. We need oxygen. Are you inhaling pure oxygen? 80% you are taking nitrogen only. Are you understanding? In reality speaking, nothing is pure. No pure metal, no pure non-metal. Are you understanding? Tell Ray. He is a professor. You are asking him doubts. Tell me. You ask me doubt, Ray. Tell me. Okay, are you understanding? Nothing is pure. When I am telling conductor means, I am telling it is a pure conductor, means it is a hypothetical only. Means I am trying to convince you induction, that's all. But in reality, metal also some non-metals are there. There are not. Mineral water means only minerals are there. Huh? Only small amount of metals are there. Huh? Plastics also there. Aerosols also there. Dust also there. Say yes or no?
The dust is also mineral, right?
Maybe mineral or not. Dust speck is, for example, ferric oxide. Oxygen is a mineral. Okay. Understood. So like that. Now, what do you notice if the non-metal, so-called, they are dielectrics. What are the name? Dielectrics are bad conductor or insulator. 3 are same only strands. Again, I am repeating. What are they? Bad conductors or insulators or dielectrics. What is the meaning of the dielectrics? They also parallelly they behave like a conductors, electric conductors, but 100% they will not behave. Are you understanding? In this pure conductor scenario, here I sprayed 10 microcoulombs of charge. If I brought a metal, how many coulombs of charge induced here? Exactly minus 10 microcoulomb. Here exactly plus 10 microcoulomb. But with the dielectrics, it is not true. Here I have one charged body. This side, how much charge is there? Plus 10 microcoulombs of charge is there. Now this time what I brought? Dielectric like plastic, mica, our pressure cooker, iron box handles are there, na? That is mica. Or understood. Little bit plastic also there, but that is an example for what here? Dielectric mica. I brought that mica here. Even water also, paper also dielectric. Now what will happen? Between dielectric also induction taking place, but that is not 100% induction. Are you understanding? 100% of the positive charges will not attract 100% of electrons. Only few electrons will be attracted. So only mildly, only very feeble induction taking place. Very feeble induction taking place. So very less amount of charge will be induced here. But surely negative charge. Yes or no? So let's say some minus only 2 microcoulomb charge. So this side will be plus 2 microcoulomb charge. For suppose if the total charge on this plate is some q coulombs of charge you have placed, and let's say its dielectric constant is K. What is K is called here? Dielectric constant. Every dielectric substance, every bad conductor, every insulator like wood, plastic, mica, it is having dielectric behavior. What is the actually dielectric constant means? It is defined as permittivity of that substance by permittivity of the free space. Now you will ask me, sir, what is the permittivity, sir? Just to break this word into two terms. Permittivity means ability of any medium to allow the electric field lines. Understood? For example, this is one positive charge and this is one negative charge. If you keep any positive charge in between them, this is fixed charge and this is also fixed charge and this is a free charge. Please respond, what will happen? This positive charge is repelled by this parent positive charge and attracted by this parent, fixed negative charge. Parent means fixed one. So the path of this positive charge is called here electric field line. What electric field line here? Electric field line. Electric field line is nothing but the path or the trajectory traveled by the positive charge in any region is called electric field line. All electric field lines will start from where to where? Positive to negative. If you take any this plate as a positive charged one, if you take this plate as a negative charged one, tell me what is the direction of electric field lines? Always the electric field lines will be starting at positive charge and where they are terminating, where they are ending, at the negative charge they are terminating. Their journey terminating at the negative charge. If you see in between these two bodies, air is there. Are you understanding? So only few electric field lines will be allowed. Are you understanding? For example, here 1, 2, 3, 5 electric field lines I have taken. In the path of the electric field line, I am keeping any metal. What will happen? Tell me. more number of electric field lines are penetrated through the metal. Yes or no?
Yes, sir.
That's what it's a dielectric constant will be infinity. Infinity means maximum. Maximum means the permittivity of the metal by permittivity of the free space. As I told, all maximum number of electric field lines are passing through the metal. So it will be what? Infinity. But in the path of these 5 electric field lines, if you keep any wood, does the wood allow all these 5 electric field lines? No, only 1 or 2 electric field lines only it will permit. Why? As I told you, wood or dielectric means 100% free electrons are not there. We cannot tell 0 free electrons also. Nothing is 100%. Says or no? So even though it is a bad conductor, even though it is a dielectric, even though insulator, it contains some free electrons. That's what.
It must be one only, no, sir.
It must be
One only, no, sir, for metal.
not 1. For metal, it is the infinity. Maximum number of is permitted is in undefined. Na Parvez. More lines are penetrating through the metal. Na?
Yes, sir.
Then undefined I have written. Something by infinity by something means infinity only. Na?
Okay.
Example, what is the concept of this dielectric constant? I will tell. Dielectric constant of water is 79. In some publication, it is written 81 also. Both are correct and nothing big difference is there. What is the actual meaning of the 79 meaning? Respond. If air is allowing 1 electric field line, but that water is allowing how many lines? 79 electric field lines it is allowing.
Sir, value for water.
This is value for water. Water is also a dielectric substance. You cannot tell it is a 100% conductor, and you cannot tell it is a 0 conductor also. Mildly conduction is there, more dielectricity is there. Are you understanding, student? Yes or no? I hope you understood the parameter called dielectric constant. Approximately, I am telling if 1 electric field line penetrating through the air or free space, how many electric field lines can pass through that water? 79. Are you understanding, everyone? Mean the water is having more free electrons comparing with to air. Air means nitrogen gas. 80% of the air containing nitrogen gas only, na? Understood. So even density perspective also water is very high. Now I can write here one more experimental observation. I brought one charged body I brought. What, Jiva? Ora? Your zoology class started, you can leave. Please leave. Neat student. Are you can stop me, no? Nicely listening.
Nice topic.
Amma, zoology class next. Please sit in this room. Next 3rd period again you have to come like this. This week alone. Okay? This week alone. Max are on leave.
Already it is neutral.
Already?
It is in neutral.
You want to charge it now. If you charge it only, this negative positive charge will go to earth, no? Then only negative charge will be there.
For charging.
Ah, yeah. Students, online NEET students also, no one is there. Please go to zoology class, okay? They are nicely listening. They are not stopping. No. You carry on. Nivasni, Aditya, Pandikavlesh, please stay. Now we will discuss some numericals. Vishal, pen driver on my table, it is there. Huh? Now numericals only. Or else CPT, what is the syllabus?
Everything not studied. Mechanical energy.
Thank you, Vishal. Students, now numerical session will start.
Sir,
No.
we do electrostatics.
I will check the CPT, so I will plan.
Conservation of mechanical energy, conservation of linear momentum.
This week teaching topics.
Stop articles. 50% is stop
Okay,
articles.
coming Monday test syllabus is there. Let me check it out. Conservation of mechanical energy, linear momentum, conservation of angular momentum, numericals will do today.
Yes, sir.
Okay.
Yes, sir.
Online students, someone say hello. Pandi Kabilesh, say hello.
Hello, sir.
Now we will do till what time, right? Till 7:40 we'll do this conservation.
Chemistry class at 6:45.
6:45 leave. 6:45 leave. Chemistry class you have. Now we'll do some problems on conservation of angular momentum. Tell Srinidhi.
You want that 20 minutes break, sir? You want morning?
This class 10 minutes break and previous class 10 minutes break. So, and you at 6:40.
Okay, it's a reasonable only.
2 class continuous.
Actually 40 minutes only, right? What 2
40 minutes, sir.
Leave at
8:15 to 8:30 you can stay and you discuss some doubts and you can leave. Then your parents will feel happy. If you are going early means they won't feel good. Okay.
Three matches if we win there. 3 out of 4 matches.
Student, this is one question. We have conservation of angular momentum. Okay, student, this is one question, very important question. A thin uniform circular disc of mass, how many kilogram? Capital M kilogram, and radius is how much? Capital R is rotating in a horizontal plane about an axis perpendicular to the plane at an angular velocity omega. And another disc, you have to visualize nicely with the diagram. This is one disc. This is what here? Axis of rotation. It is rotating with what angular speed? Omega. Its mass is how much? Capital M. And its radius is capital R. And another disc of mass capital M by 3, sorry, M by 3, not identical, but same radius, placed gently. Means slowly it is placed. Gently means coaxially placed like this. They have common axis, common axis of rotation, na? Correct or not? Now, definitely what will happen? After attaching, the new angular velocity will decrease or not? Say yes or no? So after some time, what will happen? The new angular velocity will decrease.
momentum will be same.
Let's say the new angular velocity, how much here? Omega prime. This is a system of two disks, na? This is two disks and these are two disks. Correct or not? Is there any external torque acting on our system? External forces are there, but gravitational force acting like this, normal force acting along axis of rotation, they do not contribute any torque. Yes or no? So I can write initial angular momentum of the two disks is equal to how much? Final angular momentum of the two disks. What is the initial angular momentum of the two disks? Tell me.
I omega mr square by 2 into
Only this lower disk only rotating, na? What is the angular momentum of only pure rotating body? I omega. I assumed it is anti-clockwise. Anti-clockwise means plus or minus. Very good, plus. What is the angular momentum of the another disk? Anyone, if you don't understand, stop me. What is the angular momentum of the second disk?
I by 3 into
Zero, man.
why sir?
You are placed very slowly, na? After they are combining, they start rotating with the same angular speed omega prime. Correct or not? Now tell me, what is final angular momentum of this lower disk?
I omega prime.
I will write this I1, this is also I1 omega prime. And what is the angular momentum of the upper disk?
I 2 omega.
I2 into omega prime. What is I1 value here?
mr square by 2.
Mr square only. Sorry, Mr square by 2. Disk no? Disk means Mr square by 2 into omega. Again, what a moment of inertia of the lower disk? Mr square by 2 into
Omega prime.
omega prime plus what a moment of inertia of the upper disk? Very good. Actually, Mr square by 2 only, but in the place of M, M by 3 is there and R square by 2 into omega prime. Mr square, Mr square, Mr square, 2, 2, 2 cancels out. So omega equal to how much? Omega prime plus omega prime by 3. 1 plus 1 by 3 means what here?
4 by 3.
4 by 3 into omega prime. So what a new angular speed equal to 3 omega by 4. Option 3 is the right answer for the question. Okay. Everyone understood, no?
Second for the last. I got confused because it was 4 by 3.
So which is the right option? Option 1 only the correct. Sorry, option. Yeah, 3 is the correct answer. Sorry. $50. 50.
Turntable means this one, right, sir?
Rotating table, turntable means.
A well like this. It can be also like this. Sorry, you have to visualize.
Okay. We'll try this problem. A turntable is rotating in a which plane? Horizontal plane about its own axis at an angular velocity how much? 90 rotations per minute. I mean every minute how many times it is rotating? 90. While a person is on the turntable at its edge, if he gently walks to the center of the table, by which moment of inertia of the system decreases by how much percentage? 25%. Then the time period of the rotation of turntable, how much is asking? Everyone understood? Huh? I will do this. See, this is one turntable, means rotating table only. Initially, where is the person? My dear students, initially, where is the person I am asking you? At the edge, it is rotating with what angular speed? 90 rotations per minute. After in the second situation, where that person gone? Please respond. He went to center. When he went to center, as per the data, moment of inertia decrease means angular speed will increase only, na? Why? Angular momentum is conserved, means I into omega should be constant, means I is inversely proportional to omega. If total moment of inertia decrease means angular speed of the turntable should be increasing only. Yes or no? That's what if you notice the fan orientation, as you are going away from the center, mass will decrease. Have you noticed whether propeller or wings of the fan? At the middle, mass will be very heavier. If you see the dimension also is getting decreased because of this reason only.
Sir, option 1, sir.
Are you understanding or not understanding?
Sir, option 1.
Option 1, Srinidhi is saying option 1. I don't know, we have to check. So what a new angular speed? Let's say omega prime. Here also shall I apply conservation of angular momentum. I will assume this is I. What a new moment of inertia?
3I by 4.
Decreases by 25%. Means new moment of inertia how much? Initial moment of inertia minus 25% of moment of inertia. So how much? I minus 25 by 100 into I. I minus I by 4 means what? 3I by 4. So I can write what is the initial angular momentum equal to? Final angular momentum. What is initial angular momentum value? I into omega. Omega means 90. Please stop me immediately. What a moment of inertia? Second case. Very good. 3I by 4 and into omega prime. I gets cancels out. What a angular speed equal to? 360 by 3. 3 ones are 3 ones are 3 twos are 3 zeros are. So what a new angular speed? 120 rotations per minute. Understood? But is asking time period. 120 rotation per minute. One rotation equal to how many radian? One turntable one time rotated means 360 degree na, means 2 pi radian. 1 minute equal to how many seconds? 60 seconds. 0 0 cancels out. 12th neet students. Hello, ma. Please discuss slowly. You sit together and little bit slowly. Discussion is good only, but with low noise. Okay, 6 ones are 6 twos are how much? 4 pi into radians per second. What angular speed is nothing but definition. What angular speed of the turntable? Angular displacement in one rotation by time taken to complete one rotation. So 2 pi ones are 2 pi twos are. So what a time period equal to 1 by 2 second? Means 0.5 second is your answer. So option 1 is the perfect answer for the question. I hope everyone understood very well, right? Shall we try 51? See next question. A uniform cylindrical rod of mass how much here? M kilogram. And length is how much? L meter is rotating with what? An angular velocity omega. And the axis of rotation is perpendicular to axis of symmetry and passes through one of its edge faces. If the room temperature increases by T degrees centigrade and the coefficient of linear expansion is alpha, then the change in angular velocity how much is asking? Initially, we have to visualize two situations, friends. This is one cylindrical rod. How it is rotating? Please respond. How it is rotating? Rotating with an angular velocity omega, like this. The axis of rotation is perpendicular to axis of symmetry. This axis of symmetry, perpendicular line is axis of rotation. Now, next case. In the first case, what is the length of this rod? Capital L. Please respond. What is the initial angular momentum here also? I into omega. Na? You people respond. What is the moment of inertia of this rod perpendicular to length passing through center?
Square by 12.
Shabash. ML square by 12 into omega. End axis mean ML square by 3 jiva. Central axis mean ML square by 12 only na?
Passes through one of its edge faces. Passes through one of its edge faces.
Yes, sir. Yes, sir. Yes, sir. It's 3 only.
Very good. Very good. Please, thank you. I ignored it. You are perfect. Very good. Edge faces. Very good. Edge faces. How it is rotating? About the edge axis of rotation like this. Now you people respond. What is the initial angular momentum?
I omega.
I into omega. What a moment of inertia about this end axis of rotation? Shabash, ML square by 3 into what angular speed omega. I will keep aside equation number 1. After some time, temperature increased. What is the new length? Tell me. Final length after increasing temperature formula. L1 plus alpha into T only na. Wait a second. Alpha equal to L2 minus L1 by L1 into increment in temperature na. So L1 is the initial length. And L1 is the initial length. L2 is the final length after increasing temperature. This one you bring this side. What you can write? L2 minus L1 equal to how much? Alpha into L1 into T. L1 if you send that side. L2 equal to how much? Final length after increasing temperature. L1 plus alpha into L1 into T. Correct or not? What a final length will be? L plus alpha into L into T. So what a new angular speed value? How much is the question? So what a final angular momentum? Tell me what is the final angular momentum? I into omega prime. What a moment of inertia equal to M into L square means L plus alpha into L into T whole square by 3 into omega prime. Correct or not? Shall I equate them both? Why? No torque is there, no external torque is there. So we can write initial angular velocity, initial angular momentum must be equal to final angular momentum means ML square by 3 into omega equal to how much? M into L plus how much this one? Alpha into L into T whole square by 3 into omega prime. 3m cancels out. So L square into omega equal to how much? L I can take outside and bracket will start at 1 plus alpha into T whole square into omega prime. L square cancels out. Omega equal to how much? 1 plus alpha T whole square into omega prime. So what is omega prime equal to here, student? Omega by 1 plus alpha t power 2. Say yes or no. Then I will take 2 upside. What will happen? Alpha t shall I take outside? Alpha t if you take outside, what will happen? 1 plus 1 by alpha t only, no? Alpha t, yeah, whole square only. Omega whole divided by alpha square t square and 1 plus alpha t power 2, no? So I will take upside. So what do you get? Omega by alpha square t square and 1 plus 1 by alpha t power minus 2. You know binomial theorem. Respond, what is the binomial theorem? This 1 by alpha t anyway very smaller than 1 only, na? Someone tell me what is binomial theorem? 1 plus x whole power minus n equal to how much? 1 minus 2 into x only, na? Do you know the binomial theorem? If x is very smaller than 1. Same concept shall I apply here? Say yes or no? So what I can write? Omega by alpha square t square into 1 minus 2 by alpha into t. Okay, change in angular velocity, na? Okay, anyway, yeah, correct only we missed. I thought I was in dilemma, final angular velocity. So you nicely recognize what a change in angular velocity means. Final angular velocity minus initial angular velocity. What a final angular velocity? Omega by 1 plus alpha into t whole square. Correct? And minus initial angular velocity how much? Omega only, no? So if you simplify this, omega will take outside and LCM is 1 plus alpha t whole square and plus 1 minus 1 plus alpha t whole square. If you simplify 1 minus bracket start 1 plus alpha square t square minus 2 alpha t whole divided by 1 plus alpha t whole square. So 1 minus 1 cancels, na? So omega into how much? Minus alpha square t square plus 2 alpha t and whole divided by 1 plus alpha t whole square. Anyway, alpha is again very small only. Shall I take 2 inside? Yeah, is correct. Because alpha is like this, generally 0.0000 something it will come. So if you take 2 inside, what you can write? 2 alpha t means this total denominator will be 1 only, na? Logically, 2 if you send inside also, 1 plus 2 alpha t will come. 2 into 0.000 something also, this total will be 0. So 1 again, if you come to numerator, omega into minus alpha square t square plus 2 alpha t. Alpha only deadly small. Power 2 means negligible. This also will be 0. So what is your answer? 2 omega into alpha t is your answer. Which is the right option? Option A is the perfect answer for the question.
So what formula use that for linear expansion?
Linear expansion, for example, yeah. Different metals will have different expansions. Some metals for small increment in temperature only, very big expansion taking place. So that is determined by alpha, coefficient of linear expansion, that equal to increment in length by original length If you raise 1 degree centigrade, yeah. How can you define coefficient of linear expansion? Increase in length per unit initial length due to increase in 1 degree centigrade is defined as alpha. L1 is the initial length, L2 is the final length. Understood, everyone? Now take a break, okay? Thank you, students. Take 10 minutes.